So let's look at this quiz question that you guys were wondering about, right? The optimism question, right? What would be the null hypothesis? Would be one optimism is equal to the other optimism, right? There's no difference in the group. Would you guys agree?
Right.
That's the null. That's always the same. Null, no difference. Now, since we don't have a concrete idea of which one is going to be higher, what is our alternative?
So when you say alternative, alternative is the alternative to equal.
Yes.
Okay.
Sorry about that, Janet.
Okay.
Yeah, I ended the meeting on accident.
It's okay.
I'm glad you guys are all technologically savvy to make it back in. So it's, imagine like a coin. But it's like a coin, right? The null is on one side and the other side of the coin is not null. Right? That would be a non-directional hypothesis. It's either or, right? Either they're the same or they're not the same. Now, if you have an informed hypothesis where you say, I know one of them is going to be higher than the other, then you have a directional hypothesis, right? So then at this point in time, the coin is one side again is the null, and the other side of the coin would be greater than. Right? Either one group is higher than the other, or the other group is higher.
Okay.
So in this instance, if we go back to the water example, we would say the kids of Flint are lower in IQ than comparison kids. So that would be a directional hypothesis.
So in this case, then, is directional synonymous with alternative?
Okay, alternative is just the name for the other side of the coin. It could be directional or non-directional.
Okay.
Good question. I apologize. It's just that whole verbiage, that vocabulary that we're building up.
Yeah.
So you always have a null and an alternative. The alternative could be a non-directional, which means, you know, you think there's a difference, but you don't know which way. Or the alternative could be a directional, where one of them is higher than the other. And let me go back, since I have this stuff here. I'm going to share the screen again. This is what we're talking about, right? So you can see how these come in pairs, right? The eighth null is always the same, but then you have this pair here is non-directional, and then this other pair here is directional, or this one here is also directional. And the H1, the one on the bottom, we always call alternative, and the one on the top we always call the null hypothesis.
Okay, that's clear for me. Thank you.
Okay, great. So where were we? I believe we're talking about defining the critical t-value and then figuring out if the value, the t-value that we calculated was bigger than the t-critical, right?
Right.
If it's bigger, then we conclude that we're going to reject the null. We say the t-value is so big that very likely there's no difference. There is a difference. Very likely there's a difference. So we're going to reject the null and we go with the alternative hypothesis. Now, so here it's this example, right? And actually these numbers are the same as the ones that you used for your worksheet 5, by the way. Right, we said first here we calculated the t-value. That's the red. That's what you calculated. And that's, you know, let's say it's around 2, right? 1.99. And the value that we looked up in the table, the critical t was 1.793. That's our line in the sand. now we see that our calculated value is bigger than the critical value. So it's in that gray area, right? So what would you guys conclude?
Alternative hypothesis and reject the null.
Yes. Right? It's not in this white space. The white space means it's not significantly different from null. And now as we go further away from 0, here is, in this case, the critical t-value is 1.793, right? So pretty much any number that's bigger than this 1.734, sorry, any t-value that's bigger, we're gonna reject our null. Now we're in this space here where we're gonna reject the null. We say, hey, this difference is too big to ignore. Everybody good so far?
Mm-hmm.
Yeah.
Okay, now so this is one way of doing it. Okay. We look
So
at,
what if you get really, I'm sorry to interrupt, but like, what if your value is like 99% and your t value from the chart is not 1.73, but the other number? I don't have that in front of me.
all right, well, let's go back here, right? What was the n? We said the sample size was 9, right? 10.
Yeah, so it'd be 9.
Right? So the degrees of freedom is n minus 1, so it's 10 minus 1 is 9, right?
Right.
Now we said we look at the 5% level. No, wait a second, it wasn't 9. It was something else. Oh no, sorry. It was 20. We did
Okay.
two groups. There's 20 minus 2, so it's 18 was the degrees of freedom. So that's why we got this 1.734. Right?
So if you have 2 groups, you add them together?
Yes.
I did that wrong. I didn't do that right then. Okay.
So when we have the 5% level, it would be 1.734, right? Because of this 5%. And we're doing a one-tail test, right? We're in this scenario here, right? If we now had the 1% or the 99% level or 1% level here, right, we would have to go to this column here where the 1% is at. So it's from 1.734 over, so the critical t-value now will be 2.552. Right, so that's the scenario where you're saying if we test at the 1% level, that blue area here, that critical area would move all the way out here to the 2.55. Okay, so in that case, the calculation is the same for our t critical, for our t value, right? We still would calculate 1.992, but now the critical t value is way over here, so we would still see our calculated value in the white space. It would still not be statistically significant, so we would retain the null. So the critical t-value is what moves around, and this critical t-value depends on the sample size. All right, if you go back, let's say we're at the 5% level. Well, with 20 we get 1.734, but if we only have, let's say, 10 people, 5 people in each group, we would have 10 minus 2, we would have 8. So the t critical will be 1.86. right? Let's go even smaller. Let's say we would have a degree of freedom of 5. The critical t-value would be 2. So now in this instance, right, where we calculate 1.99 is smaller than 2, so we would still retain the null hypothesis.
So the -2 was from adding the two groups together?
Yeah.
Or where is the two? Because it was 1 and then it went to 2?
Yeah, so it's n minus 1 for each group.
Okay.
So it's, let's say if you have two groups of 5, it's 5 minus 1 is 4, and then 5 minus 1 is 4, so it's 8. Or then some people say add both groups together, -2 at the end.
Okay.
So that's where that's coming from. Good question.
Thanks for asking that question, Janet. I had the same one.
Yeah, good question.
So when we talk about significance, since we're testing the null, because I heard you say, like, if it's in the white area, it's not significant. So meaning it's not significant enough to reject the null. Is that what you're saying?
Yes.
Okay.
Yes. See, because that's kind of where usually students that are or usually if you're not familiar with statistics, you say, oh, one group had 500, the other one had 502. Well, you know what? 502 is higher than 500, right? Maybe you guys, if you have, do you guys get like measured by test scores once in a while? All the time, I imagine, right? And then maybe sometimes you let's say your class is just a little bit below average, right? But then people might tell you, hey, you're a below average, blah, blah, blah. But really, those measures are, they all come with an error margin, right? So you could say, hey, I might be lower than average just as far as a number are concerned, but it's probably not statistically significantly lower. So that's kind of that notion there that
Gotcha.
we don't, yeah, every time we think about, we should, and we always make these mistakes, we should not think of points as much as of little bandwidths, little boundaries, right? Or with students as well. Like, for example, for you guys, if you guys have a quiz and, you have 90 points, or let's say you have 89 points. And usually, people say, oh, yeah, okay, 90% is an A and 89 is a B. Well, in the end, that doesn't really, there's always fluctuation. So it doesn't really, I don't think we can be that precise anyways. So, yeah, that's this. And now I don't want to confuse you guys, but what's important to see, have you guys seen this p-value, right? And the p-value is the probability of getting such a value or higher. Okay, so if you calculate a 1.992, you can actually calculate a p-value, a probability of getting this value. Right? So if you look at that whole red area, the probability to be in this red area is 0.0388. Right? So if 1 is 100%, then you have this would be 3.88% of the values are in this red area. Okay? So this is another.
Was that in a table going from the T to the P?
Yes, in the table, the one that we just looked at.
Well, I'm just looking at the p-value 0.0388. Was there a table to backtrack and go find the p, or was there a formula, or how'd you know that?
Yeah, good question. So the way I calculated that, but there's not really a. I used a calculator to do it. For example, in Excel, you'll see that when you look at the solutions, right? In Excel, we can calculate the p-value of a t-value.
Oh, okay. Okay.
So basically, what it's based on is you have this graph here, right? And each of the values has a certain probability associated with it. So that's the other way to doing it, right? One way is to look at the critical t-value and then figure out, are you in the area or not? But if you just do it that way, you wouldn't know how far along you are. You just see, in this example here, just see, hey, my t-value is bigger than 1.734, right? But you don't know how big or how small it is, right? Now, if I told you the p-value, if you calculate the p-value, then you know the exact probability. And what you're wondering now is, well, since it's the 5% significance level, my question becomes that my probability should be smaller than 5%, right?
In order to reject the null.
In order to reject the null. So we're doing the same thing, but we're kind of going from another angle at it.
Okay.
Okay. And actually that, I always think about not even talking about t critical and all that, just to say, figure out the probability of the t-value that you calculated. And if that probability of that t-value is smaller than 5%, or the p-value is smaller than 0.05, right, which is the same thing, then you reject the null. And if you look at the videos where I show you the Excel, how to do in Excel, I show you how to calculate the p-value. And then it's really straightforward. It's like a cookbook type thing, right? Where you just say, step 1, calculate the t-value, right? Everything that's associated with that. Step 2, figure out the p-value of that particular t-value. And what you need to know to do that is the degrees of freedom and the t-value. And then the program figures out which curve you're on, and then it will exactly figure out what the probability is for that particular t-value.
And then in whether you're doing one or two tail.
Yes. Exactly.
Right.
Yep. Exactly right. That, what you just mentioned, you can see here from the next slide.
Okay. Yeah.
Now this will be a two-tail test, right? We still have the same t-value, 1.99, but now you look at both sides. So you're adding the 0.0388 of one side, and then the other side has also the 0.0388. And those two added together gives you the 0.0775. And now, if that is your case, so let's make this example for Flint, okay? You and I, we say, hey, you guys have been giving those kids lead poisoned water to drink, right? We took a sample of kids from Flint, gave them IQ tests, and then we took a sample from this pristine neighbor village, right? And we figured out a t-value of 1.992, probability is 0.038, right? And because we had a clear hypothesis, we said the kids in Flint are going to have lower IQs because they've been drinking that poisonous water. Based on this, our evidence, we conclude we reject the null, we go with the alternative, right? Kids in Flint have lower IQs. And now the other guys, let's say the city of Flint, who's been serving this water to the kids, they say, We didn't have no reason to believe that there was going to be a difference. So we're testing both sides of the distribution. And we came up with a p-value of 0.0775, right, which is close, but it's still larger than 0.05. It's still in the white space. So guess what? We're going to retain the null, and we're going to say there's not really any difference between those two groups. Right? So here you can see how then statistics really becomes dependent on what hypotheses you have and what theory you have before you do your tests.
Mm-hmm.
And that's just something to be aware of. So in your worksheet, that's kind of example of the teacher, Ms. Hernandez, right? That she doesn't think that the math, the software helps, whereas the company thinks it does help. Right, so the company has a directional hypothesis, whereas the teacher is pretty neutral and has a non-directional hypothesis. So basically, what you can conclude from this is the following: when you have big differences, it doesn't matter, right? Because no matter what, you're going to reject the null. But there is this one gray area when it's between 0.05 and 10%, where it matters which way you have your hypothesis. If it's so not which way, but if you have a directional or a non-directional hypothesis. Yeah, and then the SPSS stuff you can ignore. Do you have any questions in regards to this t-test stuff? Grace, did that kind of help out with some, or? Oh, sorry.
Yeah, I saw the mistakes that I made. So,
okay. Could you share what mistakes you made? I mean,
well, one was I put the incorrect n value. I put 10 instead of 20. So the t-test, even though I calculated with the formula, it didn't match up to yours once I entered my data.
okay.
And I didn't know how to choose the critical value of the percentage. I chose 95%, but I was so worried that was wrong that I think I stopped working after that to figure out my t-value, and I think that's what I was doing wrong.
Okay, cool. Those are good. Those are good points, because those are things that weren't really that clear, right? You weren't able to find that information readily.
Okay.
Mm-hmm. So
did it say anywhere that when you have you're doing the t-test and you have two separate pieces of data that you were supposed to add those two pieces together? I didn't see that anywhere. So like if one n value was 10 and the other one was 10, I didn't know you were supposed to add those together.
I believe you're right. That it doesn't say that explicitly. That's something that I should add in the description.
Maybe you did and I missed it, but
no. Did anybody else try it already? And I'm thinking about where to add this.
and then like on 5.3, because I haven't even attempted that one, they were asking for the population, and I'm kind of confused on that part and the sample, because I thinking I have the information for the sample, but it's the ACT scores against the California state mean. So 5.3 is still kind of beyond what I know how to do.
Oh, okay. All right. So, okay, good question. So 5.3, you got to figure out. So you have the information of the sample, right? But you don't have the information for the population, right? That's what you said, right? Gosh, no, come on.
Everybody keeps losing connection.
Oh, I was already, oh, shoot. Hey, in case it disconnects, we're just going to call it a night, okay?
That's fine.
All right.
I might just head up over there tomorrow. Do you have any office hours? And I can just go see you.
Tomorrow I'm not going to be in the office, but I'm
Okay.
back in the office on Tuesday.
Tuesday?
Yeah, but feel free to, we can do more of these sessions. So feel free to email me
Okay.
and connect. So here's the thing. You're exactly at the right point, right? One sample t-test, one sample means we only have one sample, and then we test it against the value, right? We say, okay, we have information from the population. Now this here is a little bit of a tricky question because I don't really say anything, right? Now,
Right.
the ACT is a state, well, that's a federal test or global test, I don't know, but at least the whole USA takes this test. So what you can do is Google ACT test scores, and you can pull the data. So there, the trick is to go find what the norm is, and let me give you an example.
The norm of your population?
Yes.
Okay. Oh my God.
But you know what? I might have to. You know what? I'm thinking about something else now. I might just make the solutions of it because you guys, after you upload it, you see the solution, right?
Well, I can't. I didn't upload it because I haven't started this one because I just didn't even know where to begin because I felt like I didn't have all the information.
So what I feel like, because this is not a pretty compressed course, right? We have like half the time of what we usually have. So what I'll do is I'll open up the solutions so that it's less of a struggle. Let's just say that.
Thank you.
Yeah. So that you can go look at it and then you see different examples. So what you could do basically is you can take the federal norms, you can take the state norms. I don't think they're by county, but we're just talking about state and federal. But let's say other tests, right? For Fresno County or for your district, you could always pull that reference population, figure out my class. How does my class compare to that norm, right? How does my class compare to my district? How does my class compare to county? How does it compare to the state?
Okay.
So that's the idea behind the one sample t-test.
And for this particular t-test, my N value will be 20 again?
Yes.
Because
Yes, the N value will be 20 again. Yep.
okay. And when I enter the data in the Excel program, because there's ACT scores that are ones and then a group 2, am I going to do those separate or just put them all together in one, in the Excel as one column all together and do my sample mean with just one column, as one sample? I'm combining all these as one sample, or am I going to do them as two? I'm not going to do it as two separate like the t-test, right? This is a one sample test.
Yes, they're all exactly. They're all together.
All together under one. So I'm going to just have one set of calculations.
Yes.
Okay, good. Because that didn't make sense to me. Okay.
Yeah.
I'm thinking. I'm just not
See
perfect.
No, you're asking very good questions. So that, you know, that gives me also some feedback on how to share information with you guys and how to set that up. Now, could you guys check real quick? I mean, you should see the solution videos.
The one for 5.1 is there, and I looked it over, but it was really, really quiet. The voice on it was really, really quiet. I had my speaker on really high, so I needed to get some headphones and go back in and listen again. But the volume of your voice is so low, you could really not hear very well. On my computer, I don't know.
Oh, okay. So for your sample steam test. Can you see the, but can you see all the solutions? You should see all of them.
So do you have 5.3 up there now?
Yeah, it should be there.
Okay, I'll look.
Where is it? Where is solutions posted at? Inside the module?
It's in the worksheet.
Oh,
Yeah, where you go into the worksheets, it should be right below it.
No,
So module 5. Computer's slow.
I always come late.
Solution.
Just appreciate it.
Okay, I only see solution for mine for 1 and 2. I don't see 3 there.
have you uploaded one? Have you uploaded 1 and 2?
I not 3 yet. 1 and 2, yes, but
Okay,
I'm working on 3.
All right, and the other, you other people, you don't see it yet, huh?
oh, I see. Okay, I just see solutions worksheet 5.1.
Okay, yeah. So so the way it is set up is that once you upload one, that you then see the rest. But I'm gonna take this out right now so that you just see it, because it's not. I mean, you shouldn't. You shouldn't have to. This is about you guys kind of trying to figure it out, but that you can see it how it's done. Because usually, you know, we have more time where we go through it and then you practice on your own, but here you go. So Grace, thank you. You're blazing the trail.
I just feel like I'm not doing a good job, and it's really stressing me out because I'm not used to failure.
Hey, okay, so then I just want to tell you that you're doing a good job. You're asking the right questions. There's some piece of information that we're missing.
Okay, so do you know how long I worked on these worksheets?
Yeah, so
My son was so mad at me one day. He left overnight to go to my in-laws, and then he came back in the morning. I got up early, and I'm sitting there, and he's like, Mom, you were sitting there when I left, and you're sitting there when I got home. I'm like, I'm so sorry. I didn't know how to do this.
oh, I apologize. Now I feel guilty. So, but
well,
now you have the and please, if you you know, use the discussion board if you see, hey, you sense that some information is missing or something doesn't make sense. Please don't hesitate to ask that, because most of the time other people have the same questions.
Okay.
Right, and please do not doubt yourselves. Doubt in doubt the teacher, right?
Oh, and you're not used to doing that.
that All right.
Well, thank you.
You guys have other questions?
The only other thing I just wanted to clarify is just housekeeping. There's no class on this Monday, right? That's a holiday anyway, and we don't have a class scheduled, correct?
Oh yeah, I didn't even think about that. no, if is it a holiday for you guys?
It's, I think Fresno State is closed. Are they not?
Okay, all right. Well, then we'll call that. I'll post an announcement right away. What we'll do is probably schedule another meeting at a day during the week, maybe on a Thursday again. I thought it would work for more people. I'm a little bit surprised not more were able to show up, but I'll just announce it earlier, so maybe we'll have more people next time. Is Thursday, is that a good day for you guys generally?
Monday works better.
It doesn't matter.
Okay.
I'll make it one way or another.
All right. Okay. So thank you guys for coming,
Thank you.
Thank you.
and have a good evening.
You too.
You too. Bye-bye.
Have a great weekend. Yeah. Are you guys off on Monday then?
Yes.
Yes.
All right, okay, enjoy that weekend then.
Thank you.
And
Thank
depending, yeah. So what I'll see it's these things we're doing next Monday, right? For the
Right.
module 6. So
Yes.
we'll probably I'll probably extend it. So because I know
Oh,
that
thank you.
want to leave town and whatnot, so we'll do that.
How about module 6? Does that also do Monday? 'Cause-
Well, yeah, I was gonna say module 6 will extend that.
Oh,
Module,
thank you. Thank you.
yeah, module 5 should be easy to do now that I put the solutions up.
Yeah.
Okay.
You might, I'm thinking you might have people expecting a class on Monday. I'm thinking in the past there was discussion about having even though the original syllabus, didn't have one scheduled, just because it's kind of shortened up, that we might have more Mondays more often.
I thought even on the modified schedule, there wasn't one scheduled for this coming Monday. Or I could be wrong. I'm not sure.
So okay, so I'll send out an announcement and just say that we'll meet on Thursday instead.
I mean, I'm just saying I'm fine with Monday. I'm just wondering if other people were thinking that one's coming up Monday too.
I can't make Thursday, so but if that works better for more people next week, that works.
Yeah, let's do on Thursday, and then, or we can also do another one. We can add more. But if it's a holiday, then better make it. Better make it. What holiday is it anyways? President's Day.
President's Day. Yes.
Yeah. Okay. Well, then I don't want to upset the president.
I don't think. I mean, I don't have a problem with it, but I'm just saying I had gotten the impression that we might have, kind of several Monday classes. So I'm thinking that there's others that didn't come tonight, and they're thinking, okay, I'll hook up Monday.
Well,
maybe.
we'll guide them to Thursday then. We'll just say we'll have Thursday class, and then we'll add some more if you guys know, like office hours or so, when you guys want to meet once in a while.
Okay.
All right. Well, okay.
Thank
Enjoy your long weekend then.
All right.
Okay,
Thank you.
thank you.
Thank you.
All right, thank you. Bye-bye.
Oh wait, how are we getting credit for tonight? You putting something up?
Yeah, there's a quiz that you guys.
Oh, you put it up there?
Yeah.
Okay.
Okay.